This conference will now be recorded.
Hello everyone, we're starting a new chapter which is amines, and the topics that we'll discuss today: organic nitrogen compounds, which is nothing but amines, though there are several other nitrogen compounds, but mainly here amines will be discussed. And then nomenclature, classification, methods of preparation, and if time permits, we can also see some physical properties. Okay, so organic nitrogen compound, what is that we have to know, because amine is also one such compound. Organic compounds containing nitrogen, they are actually very important for our life, because there are so many biomolecules present inside our body or any other living body. If we consider, you will see that it is the naturally present molecules, biomolecules, and they have several different roles. For example, bioregulation, neurotransmitter, etc. For example, vitamin B6 molecule, if you consider, the actual active component is pyridoxine, and this is the organic nitrogen compound needed for different to maintain the health of nerves, skin, and red blood cell. Here you can see the pyridoxine structure. Fine. Here we have a benzene ring, but one of the carbon is nitrogen, so this is nitrogen containing organic compounds, and there are some other groups containing OH. Then neurotransmitter example is dopamine, so this is also benzene ring, two OH groups directly attached, and then there is alkyl chain. At the terminal position there is NH2. So this is also nitrogen containing compounds. Plants synthesize alkaloid molecules and some biologically active amines, and the purpose is to protect them for being eaten by insects and other animals, that is to protect themselves. Now alkaloids are, it is not just a single molecule, there may be different types of alkaloids. Okay, so here you can see two examples of alkaloids. Then diazonium salt. So this is the example of diazonium salt, where N triple bond N, this fragment is attached to benzene ring. So that is why, as this nitrogen is containing total, there will be 3 bonds, not 4 bonds. 3 bonds between two nitrogen atom, and this nitrogen which is carrying positive charge, because it has total 4 bonds. So that is why it will be having some positive charge. And the R group that you can say here, it may be different groups. For example, NH2, CH2H, SH, FCl, etc. Now this type of salt, they are known as diazonium salt. They have some important application in synthetic organic chemistry. Here we have a counter ion also, because the molecule is positively charged. So to balance the positive charge, there must be some negative charge, and this negatively charged A, this may be Cl minus, BF4 minus, AuCl4 minus, or triplet ion, TFO minus. Okay, so nitrogen compounds are important constituent for explosive drugs, dyes, fuels, polymers, synthetic rubbers. So there, that is, if we want to make all these molecules, then we need any nitrogen compound as starting material. So from naturally present molecule, that is biomolecules, up to some application oriented molecule that we can synthesis by ourselves, from all point of view, organic nitrogen compounds, that is amines, are very important. Fine. Classification. Now ammonia, it is a very small molecule where nitrogen, 3 hydrogen atoms are attached to it, and the formula is ammonia. Now when we are talking about amines, in general you can consider as if they are derivative of ammonia molecule, because in ammonia we have 3 NH bond, and any of this H we can replace by some alkyl group, or it may be some benzene ring or benzene derivative. Okay, so that is why we can say amines are derivatives of ammonia molecules. Now these amines you can classify as primary, secondary, tertiary, and that depends on how many hydrogen atoms are directly attached to nitrogen. So for example, that is a simple way how we can represent it. If you have, that is in any amine molecule, if you have 2 hydrogen attached to nitrogen and 1 C, now this C, it may be part of any alkyl group or benzene ring, but the important point is there must be 2 NH bond. So 2 NH bond, and there is only one NC bond. So when this condition is fulfilled, you can consider this type of amines as primary amines, or you can also call it 1 degree amine. Similarly, when there are 2 CN bond and only one NH bond, in that case it will be called secondary or 2 degree, and the other possibility where you have 3 CN bond and we do not have any hydrogen, so this will be tertiary or 3 degree. Both are fine. Now classification we will see in this way. So amines, first we have two categories. One is aliphatic amine, another one is aromatic amine. Aromatic amine means there must be presence of benzene ring or any substituted benzene ring. So come to the left hand side, that is aliphatic amine. Here under primary category, obviously now nitrogen, it must be attached with 2 hydrogen. Okay, so that is why this is the example of primary, and only one ethyl group attached with nitrogen, so there is only one CN bond. Then for secondary, two possibilities are there, mixed and simple. Because when it is secondary, now you have 2 alkyl group. Now 2 alkyl group means this 2 alkyl group, it may be similar or it may not be. So here it is similar, so it is simple. But suppose you have one methyl group, one ethyl group. In this case, you can consider it as if it is mixed secondary amine. And when it is tertiary, then also two possibilities. If all the alkyl groups, because now we will not have any NH bond, so we must have 3 alkyl groups, and all these alkyl groups, if they are similar nature, then it will be considered simple tertiary amine. But if they are different, so see here we have CH3, that is methyl, we have ethyl, and we have 3 carbon. But remember, this 3 carbon, don't call it propyl, it is actually isopropyl, because the middle carbon is attached with nitrogen. If any terminal carbon is attached, you can consider it as if it is N-propyl. That is 3 carbon terminal, but it is not terminal. Middle carbon is attached, so that is it is isopropyl. So 3 different groups are attached. Similarly, if we now focus on the right hand side part, which is aromatic amine, here maybe that is under primary only one possibility, because now you have only one CN bond. So this is basically pH group, then N, and there are 2 hydrogen. Then pH, NH, pH. So we have only one NH bond and 2 carbon nitrogen bond, and both are similar groups. So that is why it is simple amine, aromatic amine example under secondary. But if both sides you have 2 different groups, so we have pH, then we have NH bond, and then CH3. So if this is the case, now it will be considered as mixed. So it is mixed, it is secondary, and also it is aromatic. Okay, all these terms are true for this molecule. Then for tertiary, now we will not have any NH bond, and we have 3 phenyl groups attached. Fine, and all these groups are same, but it may be different also. For example, for mixed, we have one pH, one methyl, and one ethyl. Okay, so in this way, we can have the classification of amines. First, you can divide them whether it is aliphatic or aromatic, and then separately under aliphatic, we can have 1 degree, 2 degree, 3 degree, as well as simple and mixed, but that is applicable only for secondary and tertiary. Similarly, for aromatic amines also, same thing we can do. Okay. Structure of amines. Now, as nitrogen is attached to 3 group, this group may be H, or it may be some alkyl group, or it may be some benzene. Now, this nitrogen, it is also having a lone pair, and as you can understand from this structure, which is basically tetrahedral, hybridization is sp3. Now, when it is sp3, that means one s orbital, 3 p orbital will be combining together. Now nitrogen, if you consider its electronic configuration for the outermost, it is 2s2 2p3. Okay. Now 2s2 2p3, if we consider sp3 hybridization, total number of electrons 5. Now after hybridization, there will be total 4 sp3. Now in this 4 sp3, 5 electrons will be present. Now out of these 4 sp3 hybridized orbitals of nitrogen, out of these 4, only 3 sp3 orbitals will be used for bond formation with either hydrogen or alkyl group, or it may be aromatic ring also. But what about the 4th sp3? Because only 3 bonds are there. Now the 4th sp3, it will contain this lone pair. Okay, so in this way all the 5 electrons are they are filled in this 4 sp3. So if you consider actual hybridization, that is from hybridization, what is the geometry? It is tetrahedral. But as one of the position there is presence of lone pair, so ultimately the shape will be like pyramidal. Pyramidal means only focus on this part. We are just omitting lone pair. So if you omit the lone pair, then it will be having this type of pyramidal shape. So like ammonia, nitrogen atoms of amines is trivalent and carries a lone pair of electron, and this is sp3 hybridized. Now because of this lone pair, normally what we know, the angle for tetrahedral is standard angle is 109.5 degree. But because of this lone pair, now what will happen? The carbon nitrogen hydrogen bond. So CNH bond is applicable when any of these groups there will be H, then this angle will be CNH angle, and it may be CNC angle also. Suppose R3 is carbon, so it is CNC, CNH. Sorry, this is if it is H. Suppose if it is H, then this angle, these two are carbon. Okay, so this angle will be CNH. Similarly, this angle is CNC. So any of this angle that will be lesser than the standard angle that we know for tetrahedral geometry, which is 109, because there will be lone pair bond pair repulsion, and to avoid that repulsion the angle will be slightly decreased. So there is lone pair, there is electron in bond pair also, so there will be some repulsion. So avoid this repulsion, this angle or CNH angle, that is this one also you can consider, this will be slightly decreased from 109. It may be decreased to 108 or 107, and that depends on whether hydrogen is present or not. So see, here we have example, this molecule is ammonia, so we do not have any alkyl group, but this example is NMe3, that means 3 methyl groups are attached to nitrogen. So here you have NH bond. Now the size of H, obviously compared to methyl, it is less. So that is why this angle, in this case, it is 107. So they can come close to each other. I mean to say, two hydrogens, they can come close to each other. But when it is methyl compared to hydrogen, now the size is large. So obviously, if you compare now this angle, it will be slightly higher, but obviously lesser than 109, and it has to be because to avoid LP-BP repulsion. So here we have bond between N and H. Nitrogen will use its sp3, and hydrogen, it is always 1s. But when it is carbon, it may be alkyl group, that is methyl group, ethyl group, anything. Okay. So now there is sp3 of nitrogen is interacting with the sp3 hybridized orbital of carbon, because this carbon is also sp3 hybridized. Okay, so that is all about the structure of amines. Nomenclature. So when we talk about nomenclature, you can have systematic nomenclature or you can have common names. Systematic means it will be followed by some rules, and that is decided by the IUPAC. First we will see if it is common name. What we do, we treat the carbon chain as an alkyl group which is bonded to nitrogen atom, and this alkyl group will be added to the suffix amine, because now the group present is amine group. So the suffix, that is the term with which you will end the name, that is actually suffix. So amine must be at the end of the name, but before that you have to mention the alkyl group. So when it is common name, just consider this picture. You have to treat the carbon as an alkyl and just add to the suffix amine. So here we have, suppose, 4 carbon simple butane chain hydrocarbon. So what we write? We write butane. But when any of these 3 terminal hydrogen, if you replace with NH2 group, now the structure is like this, but 4 carbon. So it will be butyl, and then you have to end it with amine. If it is cyclic structure, suppose you have cyclohexane. But cyclohexane, any of these hydrogen, if you replace with NH2, now the name will change from cyclohexane to cyclohexyl, and then the suffix is amine. So here it is butyl, then amine. There will be no gap. That is just after ending. There is no such gap between butyl and amine, and between cyclohexane and amine. See, there is no gap. Okay. Now, when it is systematic name, what we will do? The same molecule again we have taken. That is, see, these 2 molecules are same. But how now you will do the systematic name? You have to choose the parent chains in such a way that longest carbon containing the carbon atom connected to the NH2 group. Though this picture is very simple, so it is not very difficult to find the longest chain, but sometimes you have to find it properly. So this is the simple hydrocarbon, that is the parent hydrocarbon if you consider, from which by replacing H you are getting the amine. So what we do? Butane spelling is butane, but when you will add the suffix amine, this E will be removed. Okay, and the name will be butan 1-amine, because the position of amine is 1. Similarly, when it is cyclohexane, you have to remove this E, last letter E, and just add amine. So it will be cyclohexanamine. Okay, cyclohexane up to this, it is coming from cyclohexane, but there is no E, and then simply add amine. So this is the difference between common name and systematic name. Now, whether it will be moving clockwise or counterclockwise, that depends on which direction is giving you the lowest number possible. So suppose you have cyclohexane and NH2, just the previous structure, but now we have methyl group extra also. Now the position of methyl, if you move clockwise, what you are getting? 1, obviously 1 will be this carbon, because NH2 is having more priority than methyl. So this is 1, but whether you will move clockwise or anti-clockwise, when you are moving clockwise, you are getting the position 3 for the methyl. So it is 1 and 3. But when you are moving anti-clockwise, now the position of methyl you are getting 5. So it is 1 and 5. So obviously this will be preferred, not this one. Okay. So if you follow the second one, which is actually not correct, you will be ending up with this name 5-methyl, because that is the position of substituent. So here methyl is basically prefix, and rest of the part there is no change, cyclohexane 1-amine. But this is not correct, because the position for this methyl substituent, it will be 3, not 5. So 3-methyl, and the rest of the part it is same, cyclohexane 1-amine. Even if you do not want to write 1, that is also okay, because the position of NH2 it is always 1. 3-methyl, in that case you can simply write 3-methyl cyclohexanamine. Fine. Suppose you do not have this structure, just after writing the name, if you are having some doubt, what you can do the reverse process. Suppose you do not have the structure in front of you, you simply have this name. Just try to write the structure and check whether you can do it or not. So from the name 3-methyl cyclohexane 1-amine, or simply 3-methyl cyclohexanamine, you can easily draw the structure. Okay, because cyclohexane, that means obviously cyclohexane is there, position of methyl is 3, so there must be some position 1 and position 3. So 3 you will place methyl and 1 you will place NH2. So yes, this is correct. In this way you can verify whether the nomenclature that you have done it is correct or not. So in this case, we are moving clockwise, but that is not necessary. Clockwise, anti-clockwise, that is not necessary. You just have to check the numbers that you are getting, whether it is as low as possible or not. Here we have another molecule, and we will try to see which method is correct. Suppose this is the structure and you are finding the longest chain like this, and it is containing 9 carbons. So parent chain, it is non-N, that is a hydrocarbon simply if you consider. Now, sorry, it is not OH, it is NH2. Another possibility is if you are finding the longest chain which is containing NH2. But in this case, you are having total 8 carbons. So parent chain is octane. But second method is correct because though it is 1 carbon less, but you have to remember that NH2 must be part of the chain. Otherwise, it is completely wrong. So if you follow the first method, suppose this is first method, this is second method. Second method, you are getting octane chain, it is correct, but NH2 is part of the chain. So that is why this method is correct. Fine. So despite being shorter, octane is the parent chain since it contains NH2 group, but non-N is not containing the NH2 group. So now the name will be, as this red line is the longest chain, 8 carbon. So this part we have to consider as if it is 4 carbon substituent. So this is actually the prefix which is present at position number 4. So it is 4-butyl because this is the prefix substituent. Then octane, but you will not write E. E you have to omit. Octane 2-amine. So position of amine must be mentioned. Otherwise, just check if you are simply writing 4-butyl octanamine, and if you try to draw the structure, you will not be able to do so because position of NH2 is not clear. Okay, so if nothing is mentioned, by default what you will do, you will end up drawing NH2 at this position 1, but that is not correct. So that is why the position 2 must be mentioned. Only when if it is 1, if you are not writing anything, then by default it will be considered 1. But if it is any other position, that position must be mentioned. So in this way we are getting complete name, which is 4-butyl octane 2-amine. Suppose there is another group, except that is not just amino, some other group is also there, and this amino group now is not the highest priority. In the previous example, some example you have seen that methyl group is present, but alkyl groups are always getting lesser priority than amino. But what if there is any group which is having higher priority than amino? In that case, what to do, that we will see. Now remember, now as amino group is not the highest priority, that means now it will no longer be suffix. Now it will be prefix. Prefix means the group which is getting lesser priority. So when the compound contains a functional group, or it may be more than one, which is having higher priority than the amino group, then it will be prefix. And remember, the suffix is basically amine, but prefix is basically amino. Okay, very slight difference. Amine Ne, amino No. But still, this is important because of this single letter. Your nomenclature may be wrong or right. Okay, so this is important. Now you cannot use amine. You have to write amino. So for example, suppose we have OH group and NH2 group both present in the carbon chain, and alcohol is always getting it is having higher priority. So now alcohol will be suffix, and when alcohol is suffix, we use the term all, and amine will be prefix amino. This also indicates we need to start numbering the carbon chain where OH group should be given the priority. And see, this is the example. So OH group and H2 group at both terminal position, and this is 3 carbon chain, but one must be given to this side because OH is having higher priority. If you are following this numbering, it is completely wrong. Okay, this is correct. Now see, prefix is 3-amino and suffix is all. 3-amino propan, but E will be omitted. Simply remember propane, P-A-N-E, but E will be omitted, and then 1 all. Here also if you do not write 1, that is if you are writing 3-amino propanol, then also it is okay because you can draw the structure. Fine. Now come to the second one, OH and NH2. Now numbering, but only one type of numbering is possible. So numbering will be started from left to right, because if you do it in the reverse order, then the position of OH and NH2 will be, suppose you are doing it like this, 1, 2, 3, 4. So now OH is 4, NH2 is 5. Just add 4 and 5, it is 9. But in this case, it is 2 and 3, which is less. So this is correct. And 2 position, NH2, which is prefix. So 2 amino, and it will be ending with all. Hexane 3 all. That is the position of OH. Now this position must be written properly, because if you do not write 3 and try to write the structure, suppose you have written 2 amino hexanol, then it is not correct, because from that name the structure that you get here, OH will be at 1, but that is not true. So that is why it must be written as hexane 3 all. And why the second one is not correct? Because in the second one we have considered OH group as prefix, and OH is, when prefix, it is not all, it is hydroxy. But this is not correct, because OH is having higher priority compared to NH2. So that is why OH will be suffix and NH2 will be prefix. Okay. So all the examples that you have seen, it is 1 degree. But what about secondary and tertiary? Because in secondary and tertiary, there will be, in the first case, 1 NH bond. But when it is tertiary, there is 0 NH bond. No NH bonds are there. Under this condition, 2 possibilities are there, depending on whether it is simple or mixed. Remember, in the nomenclature, we have seen some examples of mixed. So when it is simple, all the alkyl groups are same, but it may not be so. So that is another possibility. So first we'll see if it is identical. They are listed with the prefix di or tri. Okay, because di will be when it is secondary. For example, suppose see this structure. You have 1 NH and 2 alkyl group, both are same. Which alkyl group? It is isopropyl. It is 3 carbon. Middle carbon is connected, right? Not the terminal. If it is terminal, it will be simply propyl, but as the middle carbon is connected with nitrogen, it is isopropyl, and 2 isopropyl. So di is used, and then simply amine. And if it is tri, then triethylamine. Okay. So depending on whether 3 alkyl group or 2 alkyl group, you can mention either di or tri. So diethylamine, and rest of the position, that is diethyl means 2 ethyl groups attached to end. So the third valency, obviously that will be fulfilled by H. So we don't have to mention H. And when it is 3 degree, there is no such H, and it is trialkyl amine in general. It may be trimethyl, triethyl, etc. So this is the common name. Okay. And the other possibility, if the secondary or a tertiary amine has more than one type of alkyl group, then what we do? Now in this case, it is named following the rules of primary amine. Now what you will do, the parent chain is the longest chain bonded to the amine. So among the alkyl groups, suppose 3 different alkyl groups are there, you have to choose that alkyl group which is longest as the parent chain, and the other 2 alkyl groups, or the other only 1 alkyl group, because if it is secondary, it will be considered as substituent that are connected to nitrogen. So that is why these groups will be preceded by the letter N, but it must be in italics. And this emphasizes that they are bonded to nitrogen but not carbon. Suppose you are not using this term capital N in italics, how we will understand whether these groups are attached to carbon or nitrogen. So just to emphasize this fact, they are connected to nitrogen, we have to write capital N in italics. So let's see this example. Here we have this secondary amine where one NH bond, one methyl group and one 4 carbon chain. So first we'll find the parent chain which is longest. So in this case parent chain will be butane because this is longer than 1 carbon methyl, and the methyl group will be treated as substituent. Name the other groups as alkyl, but remember it must be preceded by capital N. So that is why it is N-alkyl, but in our case the alkyl group is methyl. So you have to write capital N methyl and the capital N it is italics. So this part is basically just like we write prefix for substituent. Remember? So N-methyl is the prefix or substituent. Then rest of the rules are same. Longest chain is 4 carbon. So butan, 1 amine. You can also write butanamine. Okay. So, and the third position there is H. So as you have mentioned N-methyl butan 1 amine. So obviously the third position, the third valency, that will be balanced by H. There is no other option. Then we have this molecule where we have 2 degree ethyl group cyclopentane ring. So this will be considered as parent. More number of carbons are attached, and this is substituent or prefix which will be used before starting at the starting part of the name. Initially capital N in italics, then ethyl, then cyclopentanamine. Remember cyclopentane, but E will be omitted. So cyclopentan, then amine. Third example, this is 3 degree. We have 2 methyl groups attached to nitrogen and we have this 7 carbon chain attached. So parent chain is obviously heptane and N-alkyl methyl, that is coming 2 times. So that is why you have to write capital N in italics 2 times. N, N hyphen then dimethyl because it is 2 times. Now rest of the part is easy. This is the longest chain and you can also see the numbering. We have done the numbering in such a way so that nitrogen gets as minimum number as possible. So the numbering is done from right hand side to left hand side. If you are doing the reverse, now this will be 1, 2, 3, 4 and this will be 5, which is not correct. So that is why this blue numbering, this is correct. N dimethyl, longest chain 7 carbon. So heptane, but E will be omitted. Heptane hyphen 3 and 3 must be written, otherwise how we will understand that 3 carbon is actually attached with nitrogen, and then suffix amine. Okay. Now the substituents in this that is to secondary or tertiary amines, they are listed in alphabetical order, and that is irrespective of whether they are connected to nitrogen or to parent chain. So there may be, see here we in the last 3 examples, these alkyl groups they are attached to nitrogen and you are considering them as a substituent, but there may be other substituent that are present in the alkyl, that is parent chain. In the last 3 example you do not have that, but in this example if you see these 2 methyl that are connected to nitrogen, but we also have a third substituent which is bromine, and the longest chain is 7 carbon and in the 6th position bromine is there. Now we have 2 methyl group, 1 bromine. Now B comes before M, so that is why you have to mention 6 bromo first, because whether bromo is attached to nitrogen or carbon, that is not important. Important thing is whether it is alphabetically arranged or not. So 6 bromo must be written first. It is not that N dimethyl then you are writing 6 bromo. No, 6 bromo first. Whatever its position, it must be before M. B comes before M alphabetically. Then rest of the part there is no change. So this molecule is basically the same molecule, that is the third example, this one. Only difference is now you have one bromine extra. So in the rest of the name there is no change, it is just like the third example in the previous case. And next see, we have another 3-degree nitrogen. So this is ethyl, this is propyl, 2 carbon, 3 carbon. And this longest chain, it is 4 carbon, but this is the methyl which is substituent at 3 position. So as it is 4 carbon, parent chain is butane, and we have substituent as N-alkyl, methyl and ethyl. But we also have another methyl which is present directly in the parent chain. Okay, but remember we have 2 methyl and 1 ethyl, but E comes before N. So N-ethyl we have written first, then N3-methyl, which is for that methyl which is present in longest chain, in 4 carbon chain. Then again you have to write N-propyl, which is for this one. So E first, M second, P third. So these are the letters for 3 substitutes, and then butan 1-amine. Okay, so butan 1-amine, even that is, if you do not write 1, then also you will end up with the same structure. So remember this, if you have some substituent present in parent chain and also substituent, that is these two are treated as substituent for nitrogen. So whatever, whether it is attached to N or C, irrespective of that, regardless of that, you have to always follow the alphabetical order. Okay. Now combining all these facts, whatever we have discussed until now, if you look at these examples, first we have the common name. So here we have the common name. This is the position isopropylamine. So this is isopropyl group, middle carbon containing NH2. But at the end we have IUPAC name. So in this IUPAC name there is no prefix. So see, there is nothing mentioned. Root word is prop because it is 3 carbon. Then primary suffix, it is alkane derivative. So ANE, but E is not used. Secondary suffix is the actual suffix, which is amine. That is a group that is present, and it is at 2 position. Next example, common name is allylamine because allyl group is like this, CC double bond then CH2. This group is allyl group. So if it is attached to NH2, it will be called allylamine, common name. But if you follow IUPAC, it is 3 carbon, but there is no other substituent, so no prefix. Then prop, we have primary suffix, it is not alkane, it is alkene derivative. CC double bond is present and the position of double bond is 2. So that is why 2 in, then 1 amine. Combining all this, it will be prop 2 in 1 amine. Then we have NH2, then followed by another NH2, but in between these two, we have 6 CH2. So it is hexamethylene diamine. Methylene means CH2 group, and 6 methylene. So that is a hexamethylene diamine. But what about the IUPAC name? Now see, when it is IUPAC name, you have to mention the position 1,6-diamine. But in this case, one important difference, the root word is hex because it is 6 carbon. But in the root word and then primary suffix n, this n is not omitted. So here we have omitted this e. But in this case, as it is diamine, so you don't have to omit this e. So it is hexene hyphen 1,6 hyphen 10. Next example, now we have secondary amine, and both sides of nitrogen there are 2 alkyl group. So common name methyl, left hand side, isopropyl right hand side. This is isopropyl. What about IUPAC? Now as we know, one of the substituent which is smaller in size, that will be treated as prefix. So this is the substituent, capital, this is actually, it should be italics. Then root word prop, because the other substituent 3 carbon, N, E is omitted, then position of amine 2. So capital N, it must be italics, then N-methyl propan 2-amine. Next example, 3 degree. We have 2 ethyl groups. So these two will be treated as prefix, so N diethyl, and this is 4 carbon. So it is root word, it will be but, N, E omitted, then 1-amine. Again we have tertiary. Ethyl methyl isopropyl amine. So we have methyl and ethyl. These two will be treated as prefix because this one is longest. So this should be considered as parent. Parent is 4 carbon, 3 carbon. So prop, N, E omitted, then 2-amine. So the name will be ultimately N-ethyl, N-methyl. E will be written before because E comes before M alphabetically. N-ethyl, then N-methyl, propan 2-amine. Then we have benzene ring. Though benzene ring we have not discussed, but see, rules are almost same. So when it is common name, this NH2 when directly attached to benzene ring, it has a specific term which is known as aniline. So for common name, it will be treated as if it is aniline derivative. So you have 2-methyl that will be treated as substituents N and dimethyl, then aniline. But when it is IUPAC, now this is prefix, then root word will be benzene because we have aromatic ring, and then suffix amine. N and dimethyl benzene amine. But in benzene, this last E of benzene is omitted. Then benzylamine. Now benzylamine is the common name because PHCH2 group. This is actually PHCH10H2, and PHCH2 group is known as benzyl. So that is why common name benzylamine. But if you consider IUPAC, now it is actually methylamine, but as if one of the hydrogen of methyl group you have replaced with phenyl. So phenyl is as if the substituent, so it will be written as prefix phenyl. Then meth is the root word because it is single carbon. N, E omitted, then methanamine. So it is not methanamine, it is methanamine. Now we have one secondary example. So one side we have benzyl group, another side we have methyl. So common name N-methyl benzyl amine. But when it is IUPAC, now N-methyl, because this is the smallest part, it will be treated as N-methyl. So it is N-methanamine. Okay. So this also you can consider as methanamine because as if normally methanamine what we consider CH3 NH2, but now as if another H is replaced by CH2 PH. Okay. So sorry, I think there is some mistake. Just ignore the last one. Fine. N-methyl benzylamine, common name is fine, but IUPAC name, this is not correct. Okay. So just ignore that part. Now we will see some aromatic and other common amines. And all the names that you are seeing here, they are basically common names. Okay. There are lots of amines. They are simply referred, that is, most of the time you will see they are referred by their common name, not IUPAC. And all these molecules that you are seeing here, they are used as organic bases and constitute a part of biologically active and essential compounds. So just consider any biological molecule which is normally very large in structure, complex structure, and in any part there may be this type of fragment. So that is why it is written as constitute a part of biologically active or essential compounds. So you can consider amino acid. Now amino acid general structure is NH2, then CH, there is some R group present, and then CO2H. Now in this R group also different types of fragment can be present. So for example, if you consider indole molecule is present as R group. Just compare with this general structure as if this is the R. So the R group is indole. and this is amino acid. Okay, so this molecule is important biologically, and the biomolecule is known as tryptophan. Then C, imidazole is present as R group in the amino acid, and this is histidine. So these are some examples. So some of them are aromatic, though not all, and some of these molecules are used as base. For example, piperidine is very good base. Pyridine not so strong like piperidine, but this is also used as base in organic reactions. Then pidol, it has also basicity. Then we have aniline, where NH2 is attached to benzene. Okay, so all these are common names. So after nomenclature, we'll see how we can prepare amine compounds. There are different methods. One by one we will see, and all these methods, they vary depending on what type of substrate you have started with. Okay, so from nitro compounds we will see how we can get amine. Obviously nitro compound means you have to use some reducing agent. So what type of reducing agent you can use? You can use H2Ni, then TnHCl, palladium H2, sometimes PDCH2 is also used, palladium on charcoal, that is carbon, and you get always primary amine. So different types of reducing agent we can use. So this is general expression. If you want to see any actual example, suppose we have taken nitroethane, alkyl chain, then NH2, we are using hydrogen Ni, or it may be FeHCl. FeHCl is not mentioned here, but that also can be used. Fe plus HCl. So here NO2 group is reduced to NH2. You can also take nitrobenzene, though this is aromatic amine we are getting, and aromatic amine will be, that is how they can be prepared. That will be discussed separately. Just you can also see that reaction here, but it will be discussed in detail separately, not here. These methods of preparation, they are basically for aliphatic amine compounds. So if you want to make aniline, obviously you have to start from some nitro substituted benzene, then same type of reducing agent, and we are getting aniline. Starting material nitrile. Nitrile means it is like this type of molecule. Here also reducing agent we will use H2Ni, sodium in presence of ethanol, and lithium aluminum hydride. Any of these you can use. Now especially if the reagent you are using sodium in presence of ethanol, then there is a specific name for this reaction which is known as Mendius reaction. Not all the reducing agent, only when it is sodium ethanol. So this C triple bond N, what happens? Total 4 hydrogens will be added. So 2 hydrogens will be attached to carbon and 2 hydrogen will be attached to nitrogen. So ultimately you will get all these double bonds will be removed, sorry, triple bond, and you will get RCH2 NH2. So in this case, suppose if you are starting from some Rx, and then that is direct starting material, if not RCN, suppose RCN you are making from Rx, then you are reducing it. So from, if you consider this is as your starting point, this is the ending point, 1 carbon is now extra. So as if this is the carbon which is responsible for this extra carbon. Okay, so in this way, if you are starting from halide, you are making RCN, then you are reducing. So it is as if 1 carbon you are increasing. Starting material RNC, isocyanate. So RCN is nitrile, but when it is RNC, so like this. Now N is positive, C is negative. Reducing agent, sodium amalgam in presence of ethanol or lithium aluminum hydride. Now in this case, what we are getting here, hydrogen 1H is added to N, and this triple bond is removed, and 3 hydrogens are attached to this carbon. So it is overall total 4 hydrogens are attached. So if it is methyl isocyanate starting material, now this part is fixed. So this part there is some change. You are getting from NC, you are getting NHCH. So now it is ultimately dimethylamine. If the starting material is amide, that means RCONH2, two methods are there. You can reduce it with lithium aluminum hydride. In this case, this CO will be converted to CH2. Rest of the part there is no change. And another important reaction, which is very important, though this reaction we have already discussed in detail with mechanism in the last chapter that we have finished, which is aldehyde ketone carboxylic acid chapter, there also detailed mechanism is given. So RCONH2 amide is basically derivative of carboxylic acid. So from that, if you consider from that point of view, so Hofmann degradation reaction we have discussed as if it is the derivative of carboxylic acid. But in this case, Hofmann degradation we are using because we are discussing preparation method of amine. So in this reaction, amine is the product and starting material is amide. Okay. So here we use bromine in presence of KOH or NaOH, not necessarily KOH, NaOH is also fine, and you get primary amine. But remember, unique thing about this reaction is that here one carbon atom is reduced less than the parent because this CO is ultimately removed. In the product, you do not have this carbon. So that is why from RCONH2, you are getting RNH2, one carbon is less. So that is why the name is degradation. One carbon is less. So this is number 4. Then number 5, if starting material is alkyl halide. Now under this one, we will see first one, Gabriel thalamide synthesis. So as we are saying the name Gabriel thalamide, obviously we will use thalamide, but it is mainly used for the preparation of aliphatic primary amine only. Now thalamide, on treatment with ethanolic KOH, first it forms potassium salt of thalamide. Now thalamide is nothing but amide, but it is different types of amide which is basically like this. This is the structure of thalamide. Okay. So CONH, because this part is present, so that is why we are calling it amide, because amide is CONH2, but this NH may be replaced by some other atoms. So that is why if you consider as if one H is replaced by CO, so this is also amide. Okay. Now in this thalamide, at this H, both side there is carbonyl group. This H is having some acidic property. In presence of KOH, this H will be replaced by potassium. Now you have N minus K plus. Now this N minus, which is now potassium salt of thalamide, can be used as nucleophile. Next, if you are using some alkyl halide, as if this is nucleophile attacking from the opposite side, following SN2 mechanism, X is removed as leaving group. So now in place of K, there will be NR bond. So this is N-alkyl thalamide, depending on what type of alkyl group you have taken. Finally, we will do some hydrolysis, alkaline hydrolysis, and our purpose for this hydrolysis is to break this carbon nitrogen bond. So ultimately, this will be broken and CONR it will be converted to CO2H, but it is KOH medium. CO2H cannot remain in CO2H form, it will be in potassium salt form. So ultimately we are getting potassium salt of phthalic acid. This is actually phthalic acid. From phthalic acid we get the term phthalanite. 2 CO2H at ortho position, and this R is removed with this N. So this total part is removed as if now it is RNH2. Okay. So this is known as Gabriel thalamide synthesis. Thalamide, we are not synthesizing thalamide. Thalamide is the starting material. So this is our actual desired product, which is 1 degree amine. By this method, remember, you cannot make aniline, though we know aniline is also 1 degree amine, PHNH2. This is also 1 degree amine. But we cannot prepare this aniline by this method because in this case, now instead of taking this alkyl halide Rx, Now you have to take ARX, or better I write, now you have to take PHX. Suppose you have taken PHBr and you are doing some SN2. But remember, nucleophilic substitution, it is not so favored for aryl halide. And why it is not favored, that is already discussed in other chapters. So that is why if you cannot take PHBr, because now this nucleophile, negative charge over nitrogen, this nucleophile cannot take part in SN2, because PHBr, aryl halide, is not good substrate for SN1, SN2. So that is why you cannot make aniline by this Gabriel thalamide synthesis. Another method where alkyl halide is again starting material, it is known as Hofmann's ammonolysis. When alkyl halide, or you can also take benzyl halide, that means PHCH2X, heated with ammonia, alcoholic ammonia, Cl2, you can get mixture of all these three types of amine. Even you can get quaternary ammonium salt. So suppose you have started from methyl bromide, you are treating it with ammonia. So that is what is ammonolysis. So first this Br will be replaced by ammonia, that is NH2, and H and Br together it will be HBr. So you are getting 1 degree amine. But suppose you have excess methyl bromide. Now this 1 degree amine, it will behave as if it is nucleophile. So this lone pair, now it can again attack this methyl. Br will be removed. So 1H and Br will be as if removed as HBr, and now you are getting Me2NH. This is also potential nucleophile. This can again attack if CH3Br is available in excess. Now you are getting 3 degree. And suppose you have even another CH3Br. This is also nucleophile. So now maximum is reached, because nitrogen cannot form more than this. Up to 3 degree it is neutral molecule, because trivalence is there. But now there are total 4 methyl groups. Nitrogen is positive. To balance this charge, Br minus is the counter. So this is quaternary ammonium bromide. You can also call it quaternary ammonium salt. So you will end up with mixture. But the product primary amine so formed, okay, it's the same thing, nucleophile, because you have taken excess halide. So this type of mixture you will get if alkyl halide you have taken extra, but ammonia is only one. So see here, all the hydrogens of ammonia as if replaced by methyl, and also there is one extra methyl. But suppose you are doing the process in such a way, now you are using a fixed CH3Br, but ammonia is now excess. So in this case, you can end the reaction at this position. So further reaction is not possible, because now ammonia is excess. Fine. So depending on whether you want to get 1 degree amine or mixture, that is up to you. You have to control the reaction in accordingly. The order of reactivity of alkyl halides is like this. So obviously here leaving group is halogen, and we know iodide is good leaving group than Br, Br is good leaving group than Cl. So that is why the substrate, how they will, the order of reactivity, it should follow this order: Ri, then Rbr, then RCl. Okay. Some more methods we will see in the next class. We are at the end of the session. Thank you for listening.